Harrison, welcome. Can you hear us?
I can, yes.
Perfect.
Quick
Well,
sound check. Can you guys hear me?
yeah, we can hear you
Absolutely.
great. Welcome to Davos and to CYSAT 2021. I was just telling you that I feel a bit bad because it's 6 a.m. your time in the west coast of the US. I didn't realize when I invited you that you had to set up the alarm at such an early time. So thank you so much. Super happy to have you with us.
Thank you. I appreciate it. And honestly, don't worry about the time. In the pandemic days, I ended up giving a presentation at 4 o'clock in the morning once. So this is
Okay.
definitely
Wow.
not the earliest.
So we're not even the worst that you've seen.
Not
Anyway,
not even the worst. I'll just ask the audience to forgive me the occasional sip of coffee, if you don't mind.
exactly. Yeah.
Um,
So please stay awake with us and see that you're ready. You're also using this advanced PowerPoint as a virtual background. Thank you so much for complying with
sure.
our strict demands to speakers. Thank you so much. And the floor is yours. And we see you after for the Q&A.
Excellent. So, as I said, please forgive me if I ramble a little bit. I'm probably not going to be at my sharpest. So I'd like to take you guys on sort of a walk through the logic that led to where we are now, and just sort of a couple of quick housekeeping points. The slides themselves have a lot of text on them that I'll be just completely skipping over. It's there so that anyone who downloads these later will have something to reference, just for recollection. So as Matthew said, a couple of years ago, I wrote paper Big Risks in Small Satellites because while I was in search of a new company to found in the space industry, I started thinking, I'll bet security is going to be a big issue in a few years if we don't do something about it. So I started reading. And, after 6 weeks of research and writing, I came back with this paper and a new perspective. Instead of thinking, hey, this is a good business idea, I started saying, wait a minute, this is a national security disaster waiting to happen. Like this, we need to do something about this right now. So I'm just going to walk through that. So to give you a sense of what we'll go through, I want to talk about 4 categories of space assets that have national and global security implications. Now, you may have noticed that when we normally talk about it, we normally only consider one category of space assets with national security implications, and those are direct national security owned and operated assets. Turns out that there are a few others. Next, we're going to talk about 3 impediments that we've been seeing to progress in securing these assets. And we're going to wrap this up with 2 requests from the OSA for you, for every single one of you here in the audience today. So just as a quick sanity check. Oh, I'm covering the text. Okay. Just as kind of a quick sanity check. If small sats, if these constellations of CubeSats are sort of meaningless and have no real impact, why are we dumping billions of dollars into them? And if they do have real serious impact, why aren't we examining them from a national security perspective? So if we look at the categories that the OSA recognizes as being important to national security, we see the first most obvious one. See, can I actually point to this? No, that's not going to work. Okay. The first most obvious one, of course, is any asset utilized directly by your nation's security services. So if you have, excuse me, if you have a commercial ComSat system used to talk to forward deployed battle groups, obviously national security. But it also includes things that are less obvious. For example, let's say my former compatriots at Spire succeed at becoming the source for weather data for the United States. Well, let's say that then the U.S. Air Force suddenly starts relying upon Spire for operations. Well, now suddenly there are, in fact, national security implications to Spire's cybersecurity and availability and integrity, et cetera. So next up, a little less obvious, anything that could be a boon to an adversary. So as all of you are probably fully appreciative of, space is hard and it's complicated. So just assume there's sort of a dangling asterisk off of nearly every statement. And I'll gloss over some of the details. Happy to circle back in Q&A. So boon to an adversary. North Korea basically lacks launch capabilities, but they do have sophisticated hacking teams. So let's say that they decide they want synthetic aperture radar capabilities in the demilitarized zone, giving them intelligence, surveillance, and reconnaissance through clouds, in the dark, etc. Okay. Well, they can't launch it themselves, but Capella Space has a bunch of satellites up there that do SAR. Do you think Pyam's built a culture of security that's going to keep North Korea out? I don't know. But it's a question we should be asking at the very least. And assets that could be useful to hostile groups like that, they should be protected. So next up, national critical functions. So this phrasing is sort of something that's been developing in the United States for a while, since at least 2000, I think, is the earliest reference I've seen, where instead of asking the question, how do we secure a point asset? Right? How do we secure the Golden Gate Bridge or the San Andreas power plant? You instead look at the functionality that those enable, the ability to cross the bay or the ability to power a hospital. And maybe you don't actually care about the asset, but you do care about the grid being up and running, power grid being up and running. Or more to the point, maybe you actually care about there being power at your water treatment facility, for example. So as it turns out, when you look at it from a functional perspective and from a systemic perspective, and this analysis was recently done by the Department of Homeland Security here in the US, they found that 52 out of the 53 identified national critical functions are dependent upon space assets in one way or another. The most obvious of which is going to be GPS, but what if you use an IoT relay system on CubeSats to manage your water district, right? Suddenly it becomes important for that to work. What if you start using an IoT relay system instead for a natural gas pipeline? Again, suddenly it becomes important that it work. It becomes important that it not be taken over by an adversarial party, etc. Finally, and this one's the most fun, physical threats. And by this, I mean basically anything with a thruster system. So you might be saying to yourself, wait a minute, we're nowhere near good enough at ionosphere modeling for a CubeSat to be used as a co-orbital anti-satellite missile. We can't predict exactly where it's going to be within a meter, 12 hours henceforth to collide with another satellite. And you'd be right. But that's not really how decisions are made, is it? Right? If you don't have to hit a 1 meter target to disrupt a mission. You have to hit let's say a 1 kilometer target. Right? All you have to do is get your 1 kilometer bubble to intersect their 1 kilometer bubble at some point, and suddenly one of you is probably going to take an avoidance maneuver for that potential conjunction event. So you get 1,000 of these things under adversarial control. Now suddenly you have the ability to disrupt missions. And even if and maybe you don't do it that way. Maybe instead you try to get within, you work over a period of months to get within, say, 100 meters of another satellite. And then you burn the thruster full tilt for 100 meters. Can you cause a collision? Can you predict where the spacecraft will be after 100 meters, or 200 meters after 10 or 15 seconds? Suddenly it becomes a lot easier. And these things are delicate. Right? They don't pass the 5-mile-an-hour bumper test. So these are the categories that the OSA feels should be protected. And they should be protected from tier 1 adversaries. This creates some really interesting incentives also. So for example, if on category 4, right, physical threats, if a foreign satellite that has a thruster system gets pwned, it is just as much a kinetic threat as if a US satellite gets pwned. So we actually, as it turns out, everyone, unsurprisingly, has some amount of skin in the game in demanding that anything with a thruster system be secured against, say, a rogue nation or state of concern or whatever the latest language is, or terrorist cell, etc. All right, let's just skip over the notes here. So, okay, let's say we agree. Let's say we want to do something about this, that we need to deal with the amount of security here. What's stopping us? Well, just as a quick sanity check again, we have dumped billions of dollars into small sat infrastructure. So of course we're going to meet resistance. Of course people are going to object, right? And even if we hadn't, I mean, nobody likes taking their medicine. So, all right, what specifically then is stopping us? Well, we found that there are three things primarily. The first is guidance. There's no definition of success, right? How much security is good enough? What does it look like to have good security? And the OSA is working on that. We put out some guidelines last year in January, jointly with a number of other organizations. And right now we're in the process of finalizing a cyber readiness evaluation methodology, right? So instead of asking, how compliant is your Maginot Line? We instead ask the question, how capable are you of repelling a tier one adversary, or more to the point, recovering from an attack by a tier one adversary? Because when you look at it, it turns out most of the time it's okay to just be able to recover. So the next one is pretty obvious, financial burden. We don't really know exactly what good security is going to look like, but we are reasonably certain it's going to be too expensive. I mean, this one's pretty easy to prove to yourself, right? A lot of the startups that are operating CubeSats, for example, can't really afford good office space, to say nothing of office space that can be physically secured, realistically. And if somebody can walk in and plug a USB key into your network, you don't have a secure office. And, you know, again, speaking as someone who has personally had a bicycle stolen from one of these facilities operating something like 100 satellites, they're not secure. They're not secure, and there's no way that they can afford it. So even if there were enough personnel available, and even if there were all the products and everything else that was necessary, they couldn't afford it. So, all right. Thankfully, this too is a reasonably solved problem. Back in January 2017, I guess it was, I worked with the FCC directly to essentially eliminate all regulatory burdens for spacecraft associated with the spacecraft being there and with the communication system. Eliminating years of time to market, getting it to where you could give me a satellite and then a week later I could have it in orbit, full global commercial operations. Now, this sort of combined infrastructure model allows us to eliminate most of the financial burden by spreading it across all of the customers. And this is realistically the only way we've seen that even has hope and a prayer of working. So what's interesting about that, and I really can't understate this, is that with the combined infrastructure model like that, the cost savings for switching from the present model of vertical integration to combined infrastructure, like using a cell phone, is those savings are so vast that right now it is actually cheaper for companies to switch to secure infrastructure than it is for them to do that themselves. So I'm going to say that again. It is cheaper to go with security. Now, this is not going to last, right? We already see a lot of horizontal plays like AWS and some vertical plays. And as soon as these organizations are allowed to take hold without offering the full end-to-end security and resilience against tier one adversaries that we need, then we'll find ourselves in the classical position of saying, hey, we need you to pay more money to add security. Whereas right now we get to say, hey, you can pay less money, and they don't actually even care what comes after that. So less money, more reliable, faster time to market. Oh, and by the way, we'll add security. So I really cannot emphasize enough what a golden opportunity this is. And I really hope that we're willing to take that. So finally, this is the part where you might be asking, oh, wait a minute, this sounds too good to be true. Why isn't this happening? And honestly, the biggest reason is monkeys, primates, right? We're all primates. And one of the things that we encounter, probably the biggest impediment we encounter, is something called the Overton window. basically sort of the window of acceptable discourse. And much of what I'm saying, much of this entire topic has been outside of this window. Buddy of mine at DHS was telling me that actually relatively recently, that's no longer the case. This is now coming into the collective consciousness, right? This is kind of the thing that causes us to ignore the person on the corner with the tinfoil hat yelling that the end is nigh. But it's also what causes us to ignore Al Gore when he says, hey, you know this climate change thing, maybe we should pay attention to that. So this is the biggest problem realistically that we face. The technological problems, we can take care of that. The financial problems, you know, if there's an investor that, you know, thinks about the future, we can take care of that as well. But the biggest problem is this is just outside of the Overton window. So that brings us to the final bit here, which is we need your help, right? This is where I'm going to ask for help. If you agree with me, we're going to ask for your help moving the Overton window, essentially. And if you disagree with me, I'm going to ask that you talk to me about that. After 2 years, we have not received any substantive pushback on the content of this. So I hope I'm not the guy in the tinfoil hat, but who knows? So the first request from us is add security, right? Let's don't just talk about it. Let's actually add security. But one tip from us, something that we found that is far more effective than telling your program manager for a space mission, hey, you should add security, is tell them you should add reliability. See, as it turns out, security and reliability kind of go hand in hand. If you put in measures to prevent unauthorized access, those same measures will prevent accidental access or accidental commands being sent. If you use theorem proving to verify one of your critical state machines, like transitions to various safe modes, then you can legitimately say that you are improving reliability. You're also making it harder for someone to force your spacecraft into a safe mode. So talk about reliability. We've actually seen contracts get over the line because we changed the rhetoric from one of security to one of reliability. And finally, just talk about security. Just talk about it. Don't sell, don't preach, right? Just help, humans, like all good little monkeys, respond to what the other monkeys are saying. So, be one of the other monkeys that just speaks about the sort of national and global security implications of small sats as though it were an already accepted conclusion. That is our request to you, is just talk to people. And I do actually, on this note, I do actually want to extend a sort of a congratulations and a thank you to CYSAT, right? It actually takes a lot of courage to think in a forward manner like that and actually do something when you have a business on the line, and actually do something outside the Overton window like that. So congratulations and thank you again, guys.
Yes, thank you, Harrison. We appreciate your support. It is true that it takes a bit of courage and risk. And Patrick is an entrepreneur, so he knows about taking risk. It's part of the journey of the company.
Absolutely.
Which we decided to venture into space about 2 years ago. We had no idea what was coming up. And then we are sitting here at CYSAT interviewing you and other top-level executives in Europe.
Yeah.
Talk about it. Let's talk about it.
Yeah. I think it's important to, if you want to develop some business, you need to take some risk, and you need to analyze the risk. And the cybersecurity risk is one of these risks you need to analyze, and for internally for our development too, as for our client or potential partner for the infrastructure that we will provide to the customer of this partner.
Your presentation was extremely clear. I'll just rephrase, so it's not yet questions, but just give you the highlights, and then you can correct me or complete.
Sure.
You emphasized a lot about in my notes. I wrote down the weakest link of the chain, right? You said something like even if the American or European satellites are super secure, if we leave all the others open, then it's still a matter of global security, and this is the subject of your talk, correct?
That's definitely part of it. That's especially true for the kinetic threats, right? A hunk of metal traveling at 18,000 miles per hour, if it successfully collides with, or even if it just gets close enough that it causes a potential conjunction event and forces, let's say, an infrared monitoring satellite watching for heat plumes to get off mission, that's still bad. So,
Yep.
especially with kinetic threats, it's a global security concern.
And still on this topic, we talked about a lot about satellite hacking and potential collisions. And I really appreciated the fact that you detailed a bit that scenario and threat, because it's kind of it may sound a bit like science fiction, but you drew the line between what is actually realistic and what is not. You said the 1 kilometer radius is something that we can predict, 1 meter definitely not. Can you give us more details on the likelihood or the potential scenario that could lead to an actual collision in space? Is it even something that could happen, or is it just the worst case will be collision avoidance and nobody will be harmed?
Yeah, that's a good question. I'm not the right person to give the truly detailed answer, and by detailed answer I mean, going back to first principles and actually going through the ionosphere, modeling, etc. So instead, what I'll say is that all of what I'm discussing here has been thoroughly vetted and reviewed by members of the national security and the intelligence community in the United States. It has been reviewed by National Security Council. It has been reviewed by orbital mechanics experts, this specific aspect of it, and two of them, with one of them saying, finally, someone's saying this out loud. And so if we go a little bit further into the details here, getting sort of, again, closer to the edge of my knowledge, I don't know I couldn't tell you the probability or which model numbers of ADCS units on the market right now would be capable of doing that. But what I can say is that if you are 1 meter away, you're gonna succeed in colliding. If you are 100 meters away, you'll probably succeed in colliding. 200 again, you'll probably succeed. And that number is just going to continue to increase as we get better, because right now it's good enough. We're just barely good enough. It seems that we could cause problems, but does anyone really think we're going to get worse at this? Right. We're putting a lot of money into things like satellite servicing, debris removal. Like, we're just, as a species, we're going to get better at this. And the better we are, the bigger the risk it is. Yeah.
It's a very fascinating topic. It sounds like a Hollywood movie trying to think about hackers finding a target and trying to get that target down. So obviously, there are a lot of parameters that would need to be investigated, but the fact is that today it's a potential threat, and I think we have to acknowledge that. Maybe one word about the Orbital Security Alliance. You mentioned some of the work you're doing there. Can you give us a quick snapshot of the OSA and especially the upcoming standards? You mentioned a couple of publications that will be released soon. I think it would be very interesting to the audience to know what you guys are working on.
So I do, of course. I have a baby who is awake, thankfully, but my wife.
Oh, sorry about that.
And no, it's okay. It's time for him to get up anyway. I do have a baby, and I'm working on a medical automation company as well that was addressing the shortage of doctors during COVID. But so this has kind of taken a backseat to a few things. But we're working on cyber readiness evaluation. So instead of asking the question, do you have the following prescribed defenses, we take a more systemic view and we say, are you ready to repel an adversary? Or more to the point, are you capable of recovering from a successful attack? How many insider threats are required before your solution is pwned. If your working keys on the spacecraft, because key management is like the biggest vulnerability we see, which is one of the reasons we love you guys. If your working keys are compromised, do you have a way to then recover access? So this is the kind of thing we're looking at in these hyper readiness levels. Other fun things we're looking at are things like, this is going to sound incredibly weird, the need from a global security and sustainability perspective to make sure that China is better armed in space. Hang on. Yep, I said that right. Okay, to make sure that China is better armed. Right. So for our safety, China needs more weapons? What? And it comes down to the concept that right now China has, in space, we sort of went straight, from an arms perspective, we went straight from sticks and stones all the way to nuclear weapons, sort of the space equivalent thereof with kinetic anti-satellite missiles. And China has already shown that they're willing to be incredibly irresponsible with those, with their 2007 test at 860 or whatever kilometers. Mm-hmm. And so they need to at least truly believe, because they've already announced that in the event of kinetic war, they're going to target our spacecraft, first thing. Mm-hmm. And so to mitigate space debris, we need them to at least believe internally and make their decisions internally as if they have a whole host of non-debris generating weaponry at their disposal, so that you don't end up with someone trigger happy generating a bunch of debris in various orbits, launching salvos of kinetic anti-satellite weapons. So there's some things we're looking at publishing mm-hmm. A little further down the road, but we're looking into, I should say, rather. But we're starting with cyber readiness levels.
Excellent. Yeah, I think it's very important to have some sort of metrics for the new space small sat operators that are not knowledgeable, that often don't have these abilities internally to gauge the resilience of their infrastructure against threats.
Yeah.
And I think that's a tool that would be widely used, especially for.
I hope so. Operators. It's also worth noting, though, that these small sat operators realistically will not have the financial resources mm-hmm. or just to change anything that they're doing. Mm-hmm. Maybe they could add a hardware security module or something instead of keeping their keys in an AWS bucket and accidentally leaving global permissions or something stupid like that. But realistically, we don't expect them to be able to do much of anything differently, because we don't expect them to be able to find the people or afford the services or infrastructure, et cetera. Yeah. This is why we are pushing so hard, saying that, if we allow horizontal plays to establish themselves without building this vertical end-to-end combined infrastructure, then suddenly we find ourselves in the same unenviable position here that we are in every other industry, where we then have to go to all of these companies and say, we need you to pay more for security. Right now, we get to tell them they can pay less for security.
Yep. I do have one last question, and then we move on. Unless, Patrick, you have one question to raise. I'll ask mine. Yeah. Obviously, you're based in the States. You've published your articles from a US perspective. What is your view on Europe in general, European actors, European technologies, European... What is your perspective on what's going on in Europe?
In a lot of ways, I find that the European space industries have their heads screwed on a bit straighter than we do here in the US. But that shouldn't be that much of a surprise, given some of the other shenanigans we've pulled over the last several years. I don't know. I really don't draw that much of a distinction, to be honest.
Okay.
It's, most of the things we're discussing still apply. There are a lot of details that end up being different. For example, the UK has an extremely low licensing barrier to spacecraft, and one of the big cost savings that you find for using combined infrastructure is eliminating regulatory burdens and licensing burdens, financial and otherwise. So there's some details change, but I don't really see you guys as being that different.
Okay. Excellent. Well, on that note, I would like to thank you very much, Harrison, for waking up at 6 o'clock in the morning for us, for being with us at CYSAT. It's really great to have you for the first edition. Thank you so much, Harrison, and have a great day.
Guys, thank you.
Thank you.